In this video, I'm going to talk about factoring and common factors. So what does it mean? First of all, what is a factor? Okay, if you have a number like 10, there are certain numbers that multiply to give 10. For example, 10 is equal to 10 times 1. It's also equal to 2 times 5. And I think those are all the products with integers, positive integers I can think of. So we say that the factors of 10 has factors 1, 2, 5, and 10. Those are all involved in products that lead to 10. Let's do another one. 5 only has two factors, 1 times 5. 1 and 5. Alright, what about 8? That's equal to 2 times 4, 8 times 1. So 8 has factors 1, 2, 4, and 8. Okay? Now, you can do something similar when you have variable blobs. 5 has factors 1 and 5. What I mean by variable blobs is you can think of pieces that multiply to give those variable blobs, okay? So let me show what I mean. So for example, x squared, you can think of that as x times x, okay? X squared, excuse me. Let me fix my writing. X squared y is equal to, you can think of that as x squared times y, or x times y. So, and I will omit 1 this time just to, let's focus on the, well, I'll go ahead and add it, what the heck. The factors of x squared are 1x and x squared. The factors of x squared y are 1x, x squared, and y. Alright? So this is going to be important later on as we learn to simplify more complex expressions. Okay? Remember when we talked about polynomials, we said that the different pieces that were added or subtracted are called terms. All right, and if the terms all have the same factor, you can do something kind of nice. Let me show you what I mean. So suppose we had 4x plus x squared. All right. The 4x has a factor, the factors 1, 4, and x. The x squared has the factor 1x and x squared. So they both terms, the 4x and the x squared, have a factor of x. What that means is you can write the sum, the purple polynomial, as x times 4 plus x. All right, let's stop right there and think about what we just did. So what I did was, when I found that there was a common factor, I put it on the outside and I left the leftovers inside the parenthesis. Okay? Now why does that work? Well, we can check that it works. Let's use our distributing skills. So we know that to distribute the x with the 4 plus x, we put it in front of the 4, and then we put the x in front of the other piece inside the parenthesis. And that simplifies to what we started with. You see that? So this is a very important process called factoring. You find if there's a common factor in all the terms of a polynomial, of an expression, and then you can put it out. You can pull it out and have a new version of the expression with parentheses. All right, that's a lot of words, so let me do a couple more examples. So how about 3x plus 6y? What do you think the common factor is there? Or 4x plus 4x squared, or alright, you might want to pause the video and try these. Alright, so the goal is to find the factored form. So the first one, they have a 3 in common. And so if you pull it out and leave the leftovers in the parentheses, you will get that purple expression. If you have any doubts, remember you can distribute it and see if you're back where you started. In fact, when you take our midterm, that's a way to check your work. Okay. The second one has more than one factor. You could factor the 4 and you would get that. Or if you notice that they have an x in common, you could take the x out and you would have got this. Okay? So what people prefer is they prefer that you take all the factors out. Okay? When you get all the factors, the common factors, put them together, that's called the greatest common factor. Okay, so the greatest common factor would be the 4 and the x, the product of the 4 and the x. So that is going to give us this green expression. So the cleanest way is, let's pull the 4x out, so 1 plus x. Look at that. Okay, we say that that's fully factored because we didn't miss any factors. Okay? And when we talk about factoring, we want things usually to be fully factored. Okay? Now the bottom one is an interesting case. There's nothing in common. There's the factors of the 10x and the 11y terms don't have anything in common. So for that one, if somebody was to ask you to factor that, you'd have to send it back and say, sorry, you're asking the impossible. All you could do is give them the same thing. Okay? So for that one, you might complain to the management and say, there's no common factor. Okay? So in other words, you can't always factor everything. That's an important point. It's not guaranteed that everything has a common factor. Okay, now even though it might not have a common factor that you could see, there's a special situation where a common factor could be quote-unquote hiding, but it's just not as obvious. All right, let me show you what I mean by that. The best way to show you is probably with an example. So how about if I had the following? Let's say let's see. Let me make sure I get this right. Alright, there. So again, this is another example where there is no common factor between all the terms. In this case, there's 4 terms. Okay, the first term, x squared, has the factors 1. Well, you always have a common factor of 1, but that's not really useful to factor out a 1. So we don't focus on that. Besides 1, the first one has a common factor of x and x squared. The second one, besides 1, 2 and x. The third term, the x, and then the 2, just 2. So you can't factor this one apparently, but watch this. You can do a process called grouping, where we group pieces of it separately, and sometimes we can get lucky that way. So let's group these in pairs like this, okay? And let's factor each pair separately. Excuse me, that way one of the pairs is not going to have still not going to be able to get factored. So let's do another adjustment first. Let's move the order. Let's move the middle 2 terms. Let's swap their position. Okay, so all I did was take the 2x and the x and put them different locations. So now this red expression is the same as the green. Okay, now go ahead and factor the first pair. You have an x in common. Okay, and on the second pair you have a 2. You have a factor of 2 in common. Okay, and now you have two terms. They both have parentheses, don't they? You have this term, x times x plus 1, and 2 times x plus 1. And notice that they have a x plus 1 in common. So a factor can be anything. In this case, a factor can be a parenthesis blob, what's called a binomial, when you have two pieces added or subtracted together. So let's go ahead and take the common binomial factor out. So x plus 1 times the leftovers, the x for the first one and the 2 for the second term. And then there's the fully factored form. Okay? This procedure is called grouping because we couldn't factor the entire expression, but we were able to, by grouping it, we were able to factor different subsets to get, and then we were able to finally put it together at the end and get a factor that was not obvious. Okay? This, again, just like before, this doesn't always work. You're not always going to get the same parenthesis, but you might want to check for this. Okay, this could happen, that there's this factor, fully factored form, and you just didn't see it. We'll learn in future classes, we'll learn more techniques to spot when this happens, that you can factor it this way and get double parentheses. Okay, let me give you another example and we'll stop with that. What about this one? Try to factor that using grouping, and I'll go ahead and tell you that this is one of those where that will work. Alright, so I'll go ahead and work it out. So the factor group them this way. So the first pair you can factor out an A, and the second pair you can factor out a B. Okay, and then they have C plus D as the common factor now, and so there you go. There's the fully factored form.